Meteorologist Matt Capucci. I want to break down exactly what happened with this fire tornado because it was not only one fire tornado, but a barrage of tornado-strength vortices that occurred inside a wildfire in northeastern California today, right along the Martin Luther King Jr. Memorial Highway. So this is what happened. You had the smoke go up to about 30,000 feet. This plume acted like a thunderstorm. The incredible heat released by the wildfire traveling upwards, just like a thunderstorm updraft. Now what happened, you had all that heat go up, and the smoke plume started to rotate thanks to something called wind shear, a change of wind speed and or direction with height. You can see the morning weather balloon from the National Weather Service in Reno shows that we had southeasterly winds at the surface, becoming more southerly and southwesterly as you go up with height. And that will cause anything that extends 30,000 feet or more to experience a twisting force, and that's exactly what happened. In this same layer, the air was nearly dry adiabatic, meaning it cooled with height at the rate of a dry parcel of air. So that means any parcel with moisture would cool less quickly and be able to rise more. And so any moisture sucked into the wildfire plume and released by the wildfire would go up even faster. And that incredible buoyancy helped stretch those tornadoes and resultantly spin those funnels. At the same time, you had local convergence or local enhancement because you get these kind of small whirls that were probably stretched vertically. Take a look. Doppler velocity shows you exactly what happened. You had one couplet right here. Here we go. One couplet right here. So blue, very strong towards the radar, red is away. And a lot of these were anticyclonic, meaning spinning clockwise instead of counterclockwise. Here's a very strong one, as a matter of fact. And when you see two colors over a very short distance, the inference is, of course, rotation is occurring. But notice how one goes and then another spins up and another spins up and another spins up. Between 1 p.m. Pacific Daylight Time and 3 p.m. Pacific Daylight Time, I counted at least 5 fire whirls, majority of which were clockwise, opposite to how most tornadoes spin in the Northern Hemisphere. And these weren't just fire whirls, these were bona fide fire tornadoes. And I think the fact that many of them were clockwise points to local boundary enhancement or orography, mountain influence or something like that, that could have helped influence how they spun. We've seen fire tornadoes before. Reading had one a couple years ago in 2018. The Isler fire back in 2014, Canberra, Australia in 2003.